Okay, today's lesson we're starting logarithms, and if we have a look at 2 to the power of 3 equals 8, so we've been looking at, we can write that in log form, and that written in log form is actually you write log to the base of 2, so the 2, whatever the base is, goes down there, so log 2, and the answer, or the equal part, of log 2 of 8 equals 3, so then the power goes here. So we're going to use a couple of rules. Now we're going to say, in general, as long as A, so we're looking at, so if the A is a real number, not 1, so as long as we don't have 1 and we have any other positive number, we can do them. And X can be any number, so the power could be any number, but the base has to be above 1, so anything bigger than 1. So if we were going to do this example here, so we can flick something to the power if it equals into a log equation using this rule. So if I look here, I've got log 32 equals x. So if I change it back to the exponential way, I can say, well, that's actually the base is 2 and the power is x, because you take from there, and then you say equals 32. Now we know we were looking at them that 32 is 2 to the power of 5, so x equals 5. So what you can actually say is, so you can say log 32 equals x. Well, you can say, then you essentially log 32 is equal to 5. Yeah, so we're trying to 5, and you can say it's equal to 5. And this is how we work it out. So we put the x there to say we don't know what it is equal to, and then we solve it like this. So this is our first rule that we'll probably use a lot, where we convert it to a log back to an index form. So we'll do some more log rules on the next page. So looking at the first log rule, and really what you'll see here, if you've got 2 logs of the same base, so see the number here is the same, we can, what you do when you're adding them, that actually is you multiply these 2 numbers. So if I look here in the example, I've got log 10, same base, I'm adding them, so that answer would equal log 10 200 times 5. So equals log 10 equals, 1,000. Log 10, 1,000. So we could write these 2 additions like that. Now, because we want to know what that is, therefore I could write log 10, 1,000 equals x, because I'm trying to work it out. And then I'll use that rule to flip it out, where we say the base of 10 to the power of x equals 1,000. So I could rewrite that 1,000 to be 10 to the power of 3, and therefore x equals 3. Okay, looking at the next logs, if we have the same logs and they're getting subtracted, we find you actually divide. So if we look at this answer, we could say that this is log 2 32 over 8, and therefore, and then we can say equals log 2 4, and then we'll convert it because we're trying to find. So therefore, if we're trying to find what log 2 4 is, so I'm just going to let it equal x and work it out, and I'll flick it around. So we've got a base of 2 to the power of x equals 4. And then I can change 2x equal 2 squared, therefore x equals 2. Okay, with this bottom one, when you have 1 over 9, that can actually be written as minus log a to the an. So you might need to draw on that at some times, and we might see it later on in our examples. So this next rule, if you have a number multiplying at the front of the log, it can be changed to become a power up here. So that's what this rule is. So we might need to do that to be able to solve our problem. So we'll look at this example. So let's change this log 10 and make it 3 to the power of 2 because it's being multiplied, and then I'll change this log 10 16 and sorry, leave that one and change this last one is log 10 6 over 15 to the power of 2. So we'll do it like that. So then you could look at this log 10. We know that 3 squared is 9, so we might convert that to a number, and we also might we'll square this one out, so that would be 36 over, sorry, that actually should be 5 up here, so we wouldn't make it that hard, so 5, let's change that. Anyway, so it's log 6, so that'd be 36 over 25, so I've squared that. So now we know about the log rules. When we could do this first bit, when we're adding, we actually multiply. So we could say that's log 10 9 times 16, and then minus the log 10 36 over 25. Okay, so then we know when we minus, we also divide. So we could say this is log 10 9 times 16 over 36 over 25. Okay, so when we have a fraction, dividing a fraction, you actually multiply by, so you got 9 times 16, you actually multiply by the flip. So I could say it's like timesing by 25 over 36. Okay, and then if you can do all your cross cancelling to make your life easier, so let's do that. So 9, or you could say 9 goes into 9 once, 9 goes into 36 4 times, and then you could say 4 goes once and 4 into 4 times, so it ends up being 4 times 25. So we've got log 10 equals 100 because 4 times 25. And then, sorry, running out of room. Now we want to know what log 10 100 equals, so we'll let it x to find it, and using that first rule I can say 10 to the power of x equals 100, but I know that 100 is 10 squared, so therefore x equals 2. Okay, when we get these rules, we might as well use that very first law that we worked out. So I might say 5 to the power of 2 equals 2x plus 1. And now I can work out 5 squared. So I'll just say 25 equals 2x plus 1, and then we keep solving. So it'd be 25 minus 1 equals 2x, 24 equals 2x, then 24 divided by 2 equals x, and 12 equals x. So there we solve for that one. Looking over here, so we've got a log of the same base minusing, so I could write that as log 2, that when you minus you actually divide, so I could put them like that, and we know it equals 4. Then I could use that first rule where I say 2 to the power of 4 equals this, 2x plus 1 over x minus 1. So we can do 2 to the power of 4, we know that's 16 equals 2x plus 1 over x minus 1, and then we can keep solving if we like. So 16 times x minus 1 equals 2x plus 1, 16x minus 16, 2x plus 1, bring the x's on one side, the numbers on the other, so get 14x equals 17, and x equals 17 over 14. There you go, and you've solved it. Okay, with this one, when we're adding logs of the same base, we know we could multiply them. So I could say log 3 equals x minus 1 times x plus 1, and equals 1. And we could use that first law where we could say 3 to the power of 1 equals x minus 1 x plus 1. So that's 3, and then you could expand that out, that's dot, so x squared minus 1 and then you could bring the 4 over here, the 1 over here, sorry, so 3 plus 1 equals x squared, so 4 equals x. Now squared, sorry, so then plus or minus square root of 4 equals x, so x equals plus or minus 2.